The next thing that we're going to look at is the idea of relative max, relative min. And I'm going to throw in absolute max and absolute min at the same time, which are also called turning points. So if you remember, I kind of showed you a picture of what a degree 3 looked like earlier. This picture right here is also a degree 3. Okay, even though it's only crossing the x-axis once in terms of its zeros, I know that this is a third degree polynomial, all based on its turning points. So point A, they call it a relative max because everything around it is slightly lower than point A. Point B down here, they call it a relative min because the points around it are a little bit higher. This is the lowest point in its general location. But points A and B, they both represent what we call turning points. So in this graph, there are two turning points. Relationship between the degree and turning points, the degree will be one higher than the number of turning points. So if I have a fourth degree polynomial, I could have 3 turning points. If I have a 12th degree polynomial, I would have 11 turning points. All I'm going to ask you to do is identify where's the relative max, relative mins, and maybe absolute max and absolute min at the same time. So we're going to look at this polynomial on Desmos. So that's where I'm going to go next. I notice that it's a degree 3 polynomial, so I'm probably going to have 2 turning points, and it's likely that I could have 3 zeros, all based on the degree. And in this case, it does. We know the zeros are where it crosses the x-axis, so each one of these represents where it crosses the x-axis. But your turning points, there is one relative max. Your relative max is located here at -1, 1, and your relative min is going to be located at that location. Okay, so that's a degree 3. Also have one that's a degree 4, so slightly different because we haven't done anything with higher degrees at this point. So in terms of a 4th degree polynomial, there should be 4 zeros, and there will be 3 turning points. That would be the general shape of the graph. So in this case, again, we have 4 zeros. It's right across the x-axis. This time I have one relative max, and I have 2 relative mins. This bottom point here and this point are both considered relative mins. Okay? Now I want to talk about what does it mean to be an absolute max and an absolute min, because I haven't talked about those yet. An absolute min, that's the one I want to talk about in this case. An absolute min is the lowest point of the graph, meaning it will not go any lower than this. So there's only one absolute min. There can only be one absolute min, one absolute max in a graph. So here is the location of your absolute min. There is no point that is lower than this location. In this case, there is no absolute max. The location that we think would be an absolute max would be this point, but notice these ends keep going higher and higher, meaning that these locations are actually higher than this point, which means that we do not have an absolute max in this case. We have an absolute min because it's the lowest point here, but no absolute max.